Okay, in 7.5, we are going to use proportional relationships. So our objective is to use ratios to make indirect measurements and to use scale drawings to solve problems. So an indirect measurement is any method that uses formulas, similar figures, and or proportions to measure an object. The following examples shows the indirect measurement technique. Helpful hint: whenever dimensions are given in both feet and inches, you must convert them to either feet or inches before doing any calculations. So if we have something that's like 4 feet, 2 inches, we have to convert it to either inches or feet first before we do anything. So first example, we have Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow and then made a diagram. What is the height h of the pole? So it gives us that his shadow is 7 feet 8 inches. What's the first thing we need to do if we have feet and inches? Convert the feet into inches. So how do we change this 7 feet into inches? 12 times 7. What's 12 times 7?
84.
And 84 plus 8, because we still need to add this 8.
90. What? Oh, wait, 92?
92.
Wait.
So we do 7 times 12.
Isn't that 84?
7 times 12 is 84, but we still have to add this 8 inches, because it's 7 feet and 8 inches.
Oh.
So 84 plus 8 is 92.
Sorry.
Okay, so the next one, we have 5 feet. We multiply the 5 by 12, and we get 60 plus 9.
69.
69.
Oh, yeah.
How many inches are in a feet?
I don't know.
12. So that's why we do times 12.
I need to learn that.
Oh, I basically did this in chemistry. We basically did this in with inches and centimeters.
I don't want to remember that.
12 inches in 1 foot. Oops.
Are we going to be doing this with like other stuff, like gallons and liters and stuff
No.
like that? Or
Just inches and feet. Okay. 60 plus 9. So for the next one, we need to do 38 times 12, which is?
What if you wanted to convert it into feet, or you can't?
We could, but we would just have to, like, we would get a decimal. 456. 456 plus 4, and we get 460. So our new measurements are 69 inches, 92 inches, and 460 inches. All right, the next thing we need to do is set up our proportions. So we have this side AB that corresponds to FG. So we're going to put the length of AB, which is 92, over what's the length of FG? 460. And that's going to be equal to the height of the man, which corresponds to the height of the telephone pole. So what's the height of the man?
69 inches.
And what's the height of the telephone pole? It gives it to us in H, so I'm just going to put H. Now what do we need to do to solve for H? Cross multiply. So we have 92H on the left, and that's going to be equal to 69 times 460. It's a big number. 1,740 and 30. And then we need to divide by 92.
It's 31,740.
31,740. And that divided by 92 is
345.
345. It's only hard because it's big numbers.
It's time.
No, there won't be big numbers on the quiz. 345 what? Inches.
You have to convert that to feet.
You can just leave it in inches. But you have to write what it is. You have to write this inches. Because if you just put 345, I don't know if you're talking about feet or inches or chickens or what. Okay, the next example, we're going to do exactly the same thing, so we're just going to skip it because I believe you guys know how to do this. All right, next we have a scale drawing represents an object as smaller than or larger than its actual size. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. For example, on a map with a scale of 1 centimeter to 1,500 meters, 1 centimeter on the map represents 1,500 meters in an actual distance. So we're going to do some examples. Remember, a proportion may compare measurements that have different units. So here we're not going to have to convert anything. So on a Wisconsin road map, Kristen measured a distance of 11 inches from Madison to Wausau. The scale of this map is 1 inch to 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? What do we need to do here?
Oh, we're not doing the scale drawing?
Do you want to draw it out? Okay. Austin, what do we do?
11 times 13. Or you would cross multiply, you would put.
What's the fraction we need to set up?
11 over x, and then.
Let's start with this one, the scale that it gave us. 1 over 13. So we have inches on top and miles on the bottom. So that's going to be equal to inches on top and miles on the bottom.
11 over x.
So since 11 is inches, we put 11 on top and x on the bottom. So now what do we do?
Cross multiply.
Cross multiply. And we get x is equal to
143.
143 inches, miles, feet. What is it?
Miles.
Miles. Because look, x needs to be miles, and it's asking us for miles. That's the answer. Ready for the next example? So find the actual distance between City Hall and El Centro College. So here, let's say this is 1 centimeter. So for every 1 centimeter, it corresponds to 300 meters for our scale. So how many centimeters on this map do you think it takes to go from El Centro College to City Hall? Approximately. It's about like 3 centimeters on our map, right?
Yeah.
So we're just taking this scale and just seeing how many times it takes us to get to City Hall. So what's our proportion we're going to set up first?
1 over 300 equals x over 3.
1 over 300, so 1 is centimeters, and 300 is meters.
Oh, wait, it would be 3 over x.
So we need centimeters over meters on the right side. So we said it takes us 3 centimeters to get from El Centro College to City Hall. So does that go on the top or the bottom?
So,
Top, because we said centimeters go on the top. So what's going to go on the bottom?
X.
X. Now what do? Cross multiply. So we get x is equal to 900 what? Meters. Because look, x has to be in meters, so it's in meters.
I got 0.9 kilometers. Is that fine?
Did you convert?
I converted.
Yeah, you don't have to convert.
No.
So where did the 3 over x come from?
3 over x, because we said it takes us, so this is like 1 centimeter. It takes us 3 of these to get from El Centro College to City Hall. So that's where the 3 centimeters, so it takes us 3 centimeters to get there. So we need to put that 3 on top. And x is the number of miles that we're trying to see what the actual distance is. So that's what we're trying to find.
So it's kind of like, you kind of like guessing
In the math one, you're kind of guessing. You're estimating.
when you take off a point, you put like a 2 instead of 3.
Well, I mean, it'll be kind of obvious. Like, you can just like use your finger and see. But just like, then just say like, this is 1 finger length. This is 1 finger, 1 finger. Okay?
Your fingers are not that.
And you don't have, like, don't use decimals. Just like round it to the nearest whole number. And the homework, I think it's pretty obvious. Okay, next one. Lady Liberty holds a tablet in her left hand. The tablet is 9 meters long and 4 meters wide. If you made a scale drawing using the scale 1 centimeter to 0.5 meters, what would the dimensions to the nearest tenth be? So in this one, we need to find the dimensions. So we're going to do a proportion to find the length and a proportion to find the width.
Why would you need to find the width even when it's asking for the?
It's asking for what?
The
The dimensions. So we need to find the length and the width. So what's our scale that it gives us? Our first ratio we need to start out with.
9 to 4, 9 over 4.
Isn't it?
Joseph.
L over 9.
What's the scale that it gives us? It says that the 1 over 0.5. So the scale for every 1 centimeter is going to be 0.5 meters. It gives us the proportion we need to start out with. So 1 is measured in what? Meters or centimeters? Centimeters. And 0.5 is? Meters. So we need centimeters on top and meters on the bottom. We're doing length to start off with. So which one measures the length? The 9 or the 4?
9.
The 9. Is 9 in meters or centimeters? So does it go on the top or bottom? The bottom.
So wait, how come you wouldn't start out with 9 over 4?
Because we need to find, it gives us this ratio. So we're not finding like, it gives us the length and width for one thing and the scale. So we need to do 2 separate problems to find like the length and the width.
So we're using the scale to find.
Yeah. Because if we use the 9 over 4 and the 1 over 0.5, we wouldn't have an x to find.
Right.
So where's our x going to go?
Top.
On the top. So what do we do now? Cross multiply. So we get 9 is equal to 0.5. 0.5 x. Now we divide by 0.5.
Is it 18?
And we get x is equal to 18. 18 feet, meters, inches, centimeters. Centimeters. Look, x, it says centimeters. So this 18 has to be centimeters. So now we need to do the same thing for width. So we use this same scale that it gives us, 1 over 0.5. 1 we said was centimeters, 0.5 is meters, and that's going to be equal to centimeters over meters. Now we're doing the width. So our tablet is 4 meters wide. No, it's 0.5. It's 0.5.
So we put the X on top and 4 on the bottom.
So we put the X on top and 4 on the bottom. Since it says 4 meters and the meters go on bottom. Now what do we need to do? Cross multiply.
Answer's 8.
So we get 4 is equal to 0.5x. We divide by 0.5. What do we get for x? 8 centimeters. That's it. The example that it gave had like decimals. So like this was like 7.9, but I made it just 9, so we didn't have to deal with decimals. You're welcome. I couldn't change this one though. So the rectangular central chamber of the Lincoln Memorial is 74 feet long and 60 feet wide. Make a scale drawing of the floor of the chamber using a scale of 1 inch to 20 feet. Joseph.
So I did like the other one, like you would like do was it like first like the feet long and then after that was the feet wide.
Uh-huh.
And then I set up like first like 1 over 20. And then like, you know, the 1 would be like the inches and then 20 would be the feet. And then I did like 1 over 20 is equal to L over 74.
Perfect. Awesome. Now what do?
You cross multiply.
Cross multiply. So we get 74 is equal to 20x, or L, whatever variable you want to use. And now we divide by 20. So we get x is equal to, how can we
3.2.
simplify this?
3.7.
How can we simplify 74 over 20?
Third,
Divided by 2.
Divide by 2. So what do we get on the top?
10.
On the top.
Oh.
Could you put in
Oh, on the
decimal
top, more.
or that wouldn't?
So we get 37 over 10,
Yeah.
and 37 divided by 10 would be 3.7.
Inches.
3.7 inches. So look, x has inches right next to it, so this has to be 3.7 inches. Now we're going to do the same thing for width. Austin, where do we start?
so you would put the, what's it called? So you would take 60 and put that over 20.
How did we start here?
Oh crap, you would put 1 over, the 20.
Perfect. And is 1 in inches or feet?
It's in inches, and then 20 in feet.
And that's going to be equal to, we need inches over feet.
So you put, 60 feet on the bottom, and then X inches on top.
Perfect. And now we cross multiply. So we get 60 is equal to 20x. Divide by 20. What do we get for x?
3. Oh my god.
3 what?
Inches.
Inches. So our question says, make a scale drawing of the floor of the chamber. So we're going to have a box with 3 inches and 3.7 inches.